Hello everyone, today we are going to talk about a very important topic of ideal gas, which is known as pressure measuring instruments. This is divided broadly into two categories, basically two types of instruments. The first one is known as barometer, whereas the other one is known as manometer. We'll first write the brief definition of these two. So what's the purpose of barometer? So it's used to measure atmospheric pressure, whereas the purpose of manometer is to measure the pressure exerted by gases. So it's basically used to measure gaseous pressure. So barometer is used to measure atmospheric pressure, whereas manometer is used to measure gaseous pressure. Now moving further, we'll write two important points. The first one is mercury is used in these instruments to measure pressure. Basically in both barometer as well as the manometer, mercury is used to measure pressure. Basically it's used as the working liquid in these two instruments, right? And the second point is, this is also important, that both of these instruments, basically both of these barometer as well as the manometer, are based on Pascal's law. Basically their working principle is based on Pascal's law. We'll discuss about Pascal's law later. Now I'll draw a diagram over here. We have to find the value of F2. We are given F1, A1. Similarly we are given A2, but we have to find F2. These are point 1 and 2. Basically you can see they are at the same level. So pressure 1 is equal to pressure 2 because they are not moving. So the formula of pressure is force divided by area. So we'll write F1 by A1 is equal to F2 by A2. So 10 by 1 is equal to, what is F2? We have to find out. What is A2? It is 100. So F2 will come out to be 1000 Newton. Right? Now moving further, we'll talk about barometer in detail. So what's the purpose of barometer? We discussed earlier. We'll quickly write it over here again, that it's used to measure atmospheric pressure. Right? It's used to measure atmospheric pressure. Now we'll draw a diagram to represent our barometer over here. You can see the vacuum is present at the top, whereas below of it, it's all mercury, which is filled at height 76 centimeter. You know why we have taken 76 centimeter? Because only then the atmospheric pressure that will be exerted will be 1 atm. We have discussed about this in our previous lecture. What is 1 atm? It is 1.01325 into 10 raised to our 5 Pascal, right? Now moving further, we'll solve a problem so you better understand. Here we have to find the value of L, basically the inclined height. We are given 76 centimeter of mercury is the atmospheric pressure, and mercury liquid is filled all over here, and height of the upper liquid column is 15 centimeter. Let's suppose this height is h and this angle at which it is inclined is 30 degrees. So sine 30 degree will come out to be s divided by L, right? So h will be L by 2, right? Similarly, using these height, we can write that 75 should be equal to this 15 plus this height h, right? So h will come out to be 60 centimeters. So what will be the value of L, which we have to calculate? It will be 2 times h, which is 2 times 60. It will come out to be 120 centimeters. So this will be our answer. Now moving further, here's a very important question which can be asked as objective type in JEE Main. So why mercury is used as working liquid in barometer? So there are two reasons. The first one is density of mercury is the highest among all liquids. That's why it's used. The second point is Hg. Mercury is almost a non-volatile liquid. Mercury is almost non-volatile liquid, hence condition of vacuum is maintained. Basically we have to maintain the condition of vacuum inside the barometer, hence we use mercury. Also its density is highest among all liquids. These are two broad reasons why we use mercury as working liquid. Hope you understand this.